Right now, we have a project going on where we're taking seafood processing wastewater and seeing how well our worm beds treat that water. We're looking at how well does our system react to seafood water, because seafood wastewater can be high in certain things like fats and oils, heavy metals. It can have high salinity, and we're really interested to seeing how the worms and the associated microbes react.
My name is Angie Hunt. I'm an assistant professor in sustainable seafood processing at Oregon State University. Well, in terms of wastewater with the seafood industry, it's always been an issue, and permitting is becoming more and more strict. There's a lot of money that is generated from seafood, but the margins are not as big as you would expect. Finding ways that will help them treat the wastewater in a way that it'll be clean and acceptable for permitting standards and be economical, kind of the win-win. Thinking outside the box. We're in that stage of needing to in order for the industry to remain viable.
The goal is here to essentially get enough data so we can say, can we do a larger scale project? And there are millions of gallons of water that need to be treated down at the Oregon coast. I mean, it's incredible. And when you think about all the seafood that comes out, whether it's crab or shrimp or fish, there is a lot. And with DEQ changing other rules, there is no good plan to treat all this water. But we're going to try to find out if we can. We think we can do some things.
To me, the worms really present this simple, elegant, natural system to treat a complex problem. So rather than having to rely on chemicals or external, large energy combustions, it's just worms, some sawdust, and the water. We also have breweries in our area that are dealing with having to treat their water in a similar way. How can we kind of use that industrial symbiosis model to help others besides just the seafood industry?
And so part of this trial that we're doing is to find out what piece can we play? Can we produce compost that goes to somebody along the way? Can we clean the water enough so it could be discharged into a wetland or something like that? How can we do this in such a way so that it doesn't cripple industry, but also can make industry much more sustainable and long-term and give them a hope for the future?
It's been kind of an exciting journey. I mean, for me, kind of thinking of it as the tortoise and the hare. People talking about the anaerobic digester and the byproduct recovery center, and these were kind of these bright, shiny, out-of-the-box technologies with a lot of promise and potential, but as conversations have advanced, there's been challenges and obstacles, and price tags are a big piece of that. It's kind of making people in our area, Astoria, rethink like what's the best strategy. And so all the way in the background is kind of the worms. What can the worms do? What can the worms do?
The preliminary results of our study were encouraging, and now that the pilot is complete, we are excited to share that vermifiltration significantly reduced the biological oxygen demand, total suspended solids, and oil and grease. As we advance our efforts to develop a mixed water system with seafood and brewery water, the next step will be to establish a baseline for the brewery water only.